How's it going, everybody out there in pre-co land? It is the weekend right now, but I am working because that is what you are doing too, and I know you're having a good time working, and everybody's just having a great time getting stuff done on the weekend. Oh yeah! In this video, I'm going to be talking about the unit circle, which is this thing. We will talk about that in a minute, though. What I want to look at first is a few examples that you don't necessarily need to know the unit circle in order to be able to perform them. So let's just take a look. So for instance, we have something like this. The given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trig functions. Okay, well if I pick this point, and I know this point is 1, 2, 3, 4, 5 in that direction. I know it is 3 down. There's my point. It says it lands on the terminal side of an angle in standard position. So what that means is I have kind of a angle right there. And this 5, negative 3, well, it went 5 units in that direction and negative 3 in that direction. And if it wants me to find the 6 trig functions, well, I can use Pythagorean theorem and say 25 and 6 is square root 31. No, it's not. Square root 34. There we go. Let's not do another problem wrong. Okay. So pretty much all I'm going to do is get these 6 trig functions from this triangle that I have drawn right here. Always draw your triangle to the x-axis, otherwise things may get a little screwy. Alright, so here are our 6 trig functions. So I know sine is opposite over hypotenuse, so I can have opposite as negative 3 over 5, so negative 3 over 5, which means cosecant would be negative 5 over 3. And then cosine is adjacent over hypotenuse. Oh, man. Mr. Pike. Ugh. What's wrong with you? It's the weekend! Give me a break! Sorry. Opposite over hypotenuse. Opposite over hypotenuse. So negative 3 over the hypotenuse is root 34. Sorry for those of you writing in pen. And then negative root 34 over 3. You guys see that? There we go. Okay. And the other one's cosine is adjacent over hypotenuse. 5 over root 34. And that means secant would be root 34 over 5. And for tangent, we have opposite over adjacent. So we have, there's our negative 3 over 5. And cotangent would be negative 5 over 3. Cool. Just know, these ones with the square roots on bottom, we are not going to make you rationalize them if they are a free response. However, you do need to know that this is the same thing as that number right there. That is the same thing. Because if you were to multiply by square root 34 on top and bottom, root 34, we would have 3 times root 34. Square root of 34 times square root of 34 will just be 34. Okay, so you may see it like this on a multiple choice question. So be prepared for that. You can just type it in your calculator if you have a calculator, or if you don't, know that this is rationalization. I mean, if you have 1 over square root 2, this is the same thing as root 2 over 2, or 2 over square root 5 would be the same thing as 2 root 5 over 5. Right? Hopefully you're kind of catching that pattern. Just multiply by the square root on top and bottom. Alright, so here's another one we can look at. Go ahead and pause the video, make sure you write it down, give it a shot even. Alright, so with this one, if we have negative 3, negative 2, I'm going to be 1, 2, 3, down 1, 2. My point is out here. I will draw a line, make it with the x-axis, so that your angle is the inside angle there. So I know I had negative 3, negative 2 by Pythagorean theorem. I will have 9 plus 4, which is square root 13. Square root 13, if you don't believe me, do Pythagorean theorem. And then our trig function. Alright, so I will get this right this time, I promise. Sine is opposite over hypotenuse, so we have negative 2 over root 13. Root 13. Or negative 2 root 13 over 13. Either way. Cosecant, you would flip it, so it would have root 13 over 2, still negative. Cosine, I have adjacent over hypotenuse, so negative 3 over root 13. Or it could be rationalized. And secant would be root 13 over 3. Tangent would be opposite over adjacent, so 2 over 3. Negative divided by negative will make that a positive. Cotangent would be 3 over 2. Yay! Alright, so now we are going to get into the unit circle. I'm actually going to use my previous video to kind of explain this guys to you. words. That's why I'm using this video, because I was much better at words back then. No, not really. I'm about the same. But I just like the way that I said things, so enjoy.
Good, whatever, and welcome to 4.2, the unit circle. In this video, we're actually going to be looking at the unit circle, which is just going in depth with more trigonometry and awesome fun stuff with triangles. This whole thing right here is the unit circle with degrees, radians, all of the points labeled. You can memorize this if you want to. Today in this video, though, I'm going to be teaching you mainly how to derive it yourself. So how to look at, say, cosine of 2 pi over 3, which is right here, and just you're going to be able to tell me that it's -1/2. Okay. With a circle, our base equation is x squared plus y squared equals 1. So my radius is 1, my center is 0, so here is a circle, your unit circle, centered at 0, 0, and the radius, the length of every radii to any point on the circle is 1. So I have from the center to this point over here is 1, straight up is 1, straight across is -1 because you're on your negative x-axis, straight down is also -1 on your y-axis. Okay, I will also tell you that these happen, x is cosine, y is sine. Basically this is true because if I were to draw a triangle using any one of those points, then you have your x-axis, your y-axis, and this angle inside is your theta, or your angle. In order to find what the x is, well, we know this length of the triangle is 1, that length right there, because that's the radius. So in order to find that, I can use my SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So I can say cosine of theta is adjacent over hypotenuse, so it's x over 1, so x is actually just cosine theta. Likewise, y is sine theta. Tangent relates to sine and cosine by using tangent theta is sine theta divided by cosine of theta. Notice this is also y over x. Same thing when you have your coordinate pairs. Okay, so likewise, I said you can memorize this if you want to. It's not too bad to memorize, but what I'm going to do is I'm going to teach you guys a few tools using special right triangles and labeling quadrants and things in order to get this every single time correctly from any angle. Here's the first set of tools that I'm going to need you guys to basically memorize if you don't have them memorized already. These are special right triangles that you saw in geometry, where you have your 45, 45, 90. This is also 45 degrees is pi over 4, so these are the same angle. Your ratio is 1, 1, square root 2. You also have your 30, 60, 90 triangle. Pi over 6 is 30 degrees, pi over 3 is 60 degrees. Across from your 30 is 1, across from your pi over 3 is square root 3, and the longest side, our hypotenuse, is 2. If you don't remember the SOHCAHTOA thing that I was just talking about in the previous slide, SOHCAHTOA, dip your toe in water, soak it in water, SOHCAHTOA. So sine is opposite over hypotenuse. That's talking about the sides of the triangle. Whatever angle you pick, say we had 30, if I pick the opposite side from 30, that's the one not touching it, so it would be 1. The hypotenuse is always the longest side. Cosine is adjacent over hypotenuse. Adjacent just means right next to, and tangent is opposite over adjacent. So looking at some examples, if we have cosine of pi over 4, what that tells me to do is go to this angle, the pi over 4 angle, which is either one of these, and do cosine. Cosine is adjacent over hypotenuse. So I can say from pi over 4, my adjacent is 1, my hypotenuse is square root 2, so this is equal to 1 over square root 2. I don't really like square roots on bottom, so what we can do is multiply by square root 2 on both top and bottom, so that we would have square root 2 over 2. And that would be how you would leave your answer. Okay, looking at our next example, sine of pi over 3, this says go to pi over 3, and then do sine. Sine is opposite over hypotenuse. So from pi over 3, the opposite side is square root 3 over 2. So square root 3 over 2. And there would be my answer. There's no simplifying to do there. Good.
Okay, and I will say with that, again, just like we were talking about in that last example, with this, you can leave your answer like that in a free response, but you better be able to pick this answer out of a multiple choice. We are going to rationalize at some points.
The next tool we're going to need to know is how to correctly label our quadrants. So if you notice on the unit circle, some of those points had negatives in them. So this is where the negatives are coming from. If we have xy coordinate pairs, don't forget this is cosine, sine. In the first quadrant they're both positive, so then sine's positive and cosine's positive. You get tangent by doing sine over cosine. Then a positive divided by a positive will also be a positive. In the second quadrant, only your y is positive, so only your sine is positive. Both of them will be negative. Likewise, in the third quadrant, they're both negative, so when you divide negatives and negatives, tangent will be a positive. In your fourth quadrant, only cosine is positive. Basically, the way that I remember this is all of them are positive, only sine is positive, only tangent is positive, and then only cosine is positive. So at the top of my papers when I was in high school, what I used to write is this all students take calculus thing. That's just how I remember it. ASTC, that's how Miss Sutter taught me when I took her for pre-cal way back when. So this is how I've always remembered it to this day. You're going to use this to determine whether you have a positive or negative angle. So in doing that, looking at an example, say I have cosine of 3 pi over 4. Our first step is going to be determine which quadrant we are in. Okay, so if I want to know what quadrant I'm in, 3 pi over 4 is a little bit less than 1. It's 1/4 less than 1, so I'm in the second quadrant. And in the second quadrant, only sine is positive, so that means that cosine must be negative. Now, this 3 pi over 4, we don't really have an angle like that in our triangles, but I'm going to look at my triangles. Triangle. Because I have this triangle where I have pi over 4 as an angle, well, that actually relates because these are both over 4. So then my ratio, 1 square root 2, I do cosine. Cosine is adjacent over hypotenuse, so the adjacent side to my pi over 4 angle is 1. The hypotenuse is 2, so I have negative 1 over square root 2, which again you'll have to rationalize to be negative square root 2 over 2. And if you look on your unit circle at 3 pi over 4, cosine, or your x value, will be negative square root 2 over 2. And I think your y value is going to be square root 2 over 2, but for this instance, this is all I need to see. Okay, so really the big thing that I want you to take away from this is how to find what is negative and what is positive using your quadrants. And the all students take calculus, or all sombreros try cantaloupe, or something, or however you want to remember it. Doesn't matter to me. Everything that you see on this page is basically my cheat sheet for trigonometry. This is what I use. This is what I used to write at the top of every quiz, every test, anything like that that I did that was trigonometry or unit circle based. This stuff is really helpful. You're going to use SOHCAHTOA a lot from now on. You may use these special right triangles a lot from now on. And of course we're going to use our all students take calculus. And these points are the pi over 2s and pi's and all the weird ones. So say for example, if you guys were given sine of 5 pi over 6. I have SOHCAHTOA to tell me that sine is opposite over hypotenuse. My first step is going to be determine which quadrant it's in, so I know that my angle is positive or negative. So 5 pi over 6 is a little bit less than 1, so we're going to be right here in the second quadrant. So if I'm in the second quadrant, sine is positive, so whatever I get is going to be positive. Now, since there's a 6 on bottom, I have a pi over 6, I'm going to use the pi over 6 as my reference angle, the angle that I'm going to look at. Sine is opposite over hypotenuse, so opposite side is 1, hypotenuse is 2, so I have 1/2. That would be it. Doesn't need to simplify any further, so that's good to go. What about tangent of, say, 5 pi over 3? Again, I'm going to look at my SOHCAHTOA. Tangent is opposite over adjacent. I have 5 pi over 3, which is a little bit less than 2. It's right down here somewhere. So that's going to be where C is positive, so where cosine is positive. So that means that my tangent angle is going to be negative whatever it is. Now I have a 3 on bottom, so I'm going to look at the angle with the 3 on bottom. Tangent is opposite over adjacent, so square root 3 over 1, which is just square root 3. And that would be your answer. Looking at another one now. If I have let's say cosine of negative 3 pi over 4. Don't forget the negative angles are going to go the other direction. So I'm going to actually start from 0 and I'm going to go the other direction. And here's negative 3 pi over 4, because this is negative pi over 2 straight up and down. That's negative pi. This is negative 3/4. So I'm in where tangent's positive, so my cosine is going to be a negative whatever it is then. Now I'm going to look at my pi over 4 angle with my triangles, adjacent over hypotenuse, so 1 over square root 2, which will reduce to negative square root 2 over 2. And there's my answer. It's simple as it gets. I'm going to look at one more example. Tangent of pi over 2. Well, pi over 2 is straight up. It's not in either of our triangles. I mean, it's kind of right here and right there, but it's not really an angle that we can use SOHCAHTOA with. It has to be one of these angles. So if pi over 2 is right here, I know that tangent is y over x. And if I'm at pi over 2, then I have 1 over 0. So if this is 1 over 0, I cannot define by 0. So this is undefined, not undefined, undefined. So you cannot divide by 0, so you would actually have undefined. If you had like cosine of...
I don't know why I can't spell apparently. UNDEFINED. There shouldn't be an N right there. Don't write that in right there, please. I'm sorry.
2, then it would just be 0. If you had sine of pi over 2, then it would just be equal to 1. Okay, there are also 3 more...
Alright, the next concept that I'm going to talk to you guys about is called the reference angle. Basically, all that means is the angle that we have made with the x-axis. So for instance, if I'm trying to find the reference angle of these two angles, I'm given 210 degrees, and I know that 210 degrees, since this is 180 degrees, well, 210 is right there. 210 degrees. The angle with the x-axis is the angle right there, and that is 30 degrees away. So my reference angle in this is just 30 degrees. So pretty much we use these when we are solving with the triangles. I'm going to use my reference angle to give the value of whatever trig function I'm trying to find. Also with 5 pi over 6, say, well, that's 5, 6. Well, I know this is pi. This is 5 pi over 6. So the difference there, or the reference angle, would be pi over 6, which is why I was just looking at the number on the bottom when I was trying to figure out the values of those trig functions that we were just looking at. Okay, now we're going to use the reference angles to actually find the values of more trig functions. Alright, so here are all the trig functions that we are going to walk through. Don't freak out, we're going to do it one at a time, don't worry, but make sure you try, especially if you are reviewing this video. Again, there's the stuff. I have it on a post-it note. I'm going to be putting it on and off the screen. But this is everything that you need to make sure that you memorize, such that you will do well. Either that or memorize the unit circle. So with this first one, tangent of 7 pi over 6, I know this is in the third quadrant. My reference angle is pi over 6. I know tangent is opposite over adjacent. So from my pi over 6 angle, I can go opposite over adjacent. So I have 1 over root 3. Since it is in the third quadrant, that is where tangent is positive. So I am done with that problem. Cool. For sine of 2 pi over 3, AS, that is in the second quadrant, so I have a positive sine angle, or sorry, sine function value. My reference angle would be pi over 3, so from pi over 3, I will do opposite over hypotenuse, so root 3 over 2. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. But notice here on this one, this is a 180 degree angle. 180 degrees is straight left right here. Since cosine is the x value, cosine is -1. I am done there. Okay, sine of 315 degrees. This is 45 degrees away from 360, so my reference angle is 45. This is in the fourth quadrant where cosine is positive, so that means sine is negative. From 45, the opposite over hypotenuse is 1 over root 2. Cotangent of 300 degrees, the reference angle here is 60 degrees, because it is 60 degrees away from the 360. Cotangent is adjacent over opposite. So then from 60 degrees, the adjacent over the opposite is 1 over root 3. I am in the fourth quadrant where cosine is positive, so that means cotangent, since it is related to tangent, is negative. There are those. Okay, looking at the other side. Halfway done. Oh yeah, I'm gonna win. Negative 5 pi over 4. Negative 5 pi over 4. Don't forget negative angles, you go around the other direction. It is bigger than 1, so I'm in the second quadrant. So I'm in the second quadrant where sine is positive. That means tangent is negative. And then the reference angle would be pi over 4, so opposite over adjacent would just be 1 over 1. Opposite over adjacent, 1 over 1 is just 1. Okay, cotangent is adjacent over opposite. Notice this is 510 degrees. Well, 510 is just more times around the circle, so if you take out a full circle from this, this would just be, what, 150 degrees? 510 minus 360, 150, yeah, 150 degrees, which would give me a reference angle of 30 degrees. It is in the second quadrant, so this will be a negative function value. And then from 30 degrees, we have adjacent over opposite, so root 3 over 1 is just square root 3. Secant of 3 pi over 2, again notice 3 pi over 2, that is on an axis that is straight down. Secant is related to cosine, but it is 1 over cosine. So if I take 0, it's like saying 0 over 1. So I need to flip that for secant, but I can't divide by 0, so this would actually just be undefined. Undefined. I can actually spell it right this time. Yay, you're so smart, Mr. Pike. I know. Thanks, Peanut Gallery. Okay, cosine 7 pi over 4. Cosine is adjacent over hypotenuse. 7 pi over 4 is all the way around in the fourth quadrant. Cosine is a positive function there. So my reference angle is pi over 4. Cosine is adjacent over hypotenuse, so 1 over root 2. Cosecant. Coral one's in here. Hypotenuse over opposite. Because it is related to sine, negative 19 pi over 6 is more than one time around the unit circle. It is the same thing as negative 7 pi over 6, which would be in the second quadrant with a reference angle of pi over 6. Sine is positive in there, so cosecant is also positive. So hypotenuse over opposite from your pi over 6 angle, hypotenuse over opposite would be 2 over 1, which then would just be 2. Whew. Okay, just 2 short examples. They'll go fast. All right, our directions here. Find the exact value of the 5 remaining trig functions. I am given that cosecant of theta is equal to 2, so then I also know that sine theta should be equal to 1/2. It tells me that sine is greater than 0, so really all that means is that sine is positive. It is a positive number. And cosine is less than 0, so cosine is negative. This helps us in determining which quadrant we are in, because I know that if I am in a quadrant where sine is positive, it is either in the sine is positive in the first and second quadrant. If cosine is negative, well, cosine is positive in the first quadrant, so it has to be in the second quadrant, since that is where sine is positive and cosine is negative. So I know when I draw my triangle, I can draw it in the second quadrant with my reference angle. If I have sine is 1 over 2, opposite over hypotenuse, which means this is going to be square root 3. And then it's just a matter of listing my trig functions. This is going to be negative square root 3 because it went to the left. Come on, let's think. So then I have left are my other trig functions, and it's pretty easy to find them. So that cosine is adjacent over hypotenuse, which is negative root 3 over 2. Secant then would be that flipped, so 2 over root 3 negative. Tangent's opposite over adjacent, so 1 over root 3 negative, and cotangent would be negative root 3. That's all there is to ones like that. Let's try one more, and then we'll be done. All right, so same directions in this one. With this one, notice you have a negative cosine value, so that tells you it is in quadrants 2 or 3. Those are the only quadrants where you have a negative cosine. If sine is also less than 0, sine is negative, then we have to be in quadrant 3. So when I draw my triangle to figure out what my angle looks like, I can draw it in quadrant 3, where I have my reference angle. Cosine is adjacent over hypotenuse, so A over H, which means that's negative 12 over hypotenuse is 13. By Pythagorean theorem, you will find that this is 5. Since it is going down, because it's in the third quadrant, I know it has to be a negative 5. And then it's just a matter, again, of just listing all your trig functions. Okay, so by my initial problem, I know that secant should be this flipped, cosine flipped. It is the reciprocal of cosine, so we have negative 13 over 12. Sine will be opposite over hypotenuse, so negative 5 over hypotenuse is 13, negative 5 over 13. Flip it for cosecant, so negative 13 over 5. Tangent should be opposite over adjacent, so negative 5 over negative 12, which will reduce to 5 over 12, and cotangent will be just the opposite. And notice, tangent came out positive because I'm in my fourth quadrant. I'm in my third quadrant. I'm in my third quadrant, where tangent is positive, so both of those values came out positive. Awesome. And sine is negative in there, so sine and cosecant came out negative, and secant was already negative because cosine was negative. Okay, make sure that you guys memorize this sheet, or you memorize the unit circle. You have to do one of the two. The easiest thing to memorize the unit circle is to kind of memorize this first section there. And then if you notice, the reference angle here is 30 degrees. Well, the reference angle here is 30 degrees. So look, their points are kind of the same, except the x value is negative because it is on the negative side of the x-axis. Likewise, your 30-degree angle down here, the points are the same, but the y's went down. Here the y's are down and the x is positive. Your reference angle of 45 will always be root 2 over 2 from both of your points. And then the 4 pi over 3, or sorry, the pi over 6, pi over 3 angle, which has a reference angle of 60 degrees, is 60, 120, 240, 300. They all have the same points, and notice they're also these points flipped. So make sure you know, if you know the 30 degrees, then really you know the 60 degrees because the x and y just switch where they are placed in the coordinate plane. Hopefully you guys memorize stuff. I know you will because you're all awesome students and you all do everything that you're supposed to be doing because Mr. Pike tells you to do everything that you're supposed to be doing. Memorize this or you will not pass. I love you guys. Sorry it was so long, but make sure you memorize it. It was long because you need to know everything in it. Love you guys. Get lots of practice on this. Bye!